Hello everyone. Today we are going to discuss the properties of inverse trigonometric functions. Inverse trigonometric function has got many important properties. Out of that, we'll be discussing a few of the very simple basic properties. The first property is this, that sine inverse sine x is equal to x for all x belonging to minus pi by 2 to pi by 2. Cos inverse cos x is equal to x for all x belonging to 0 to pi. And similarly the remaining properties. Now let us see how these properties can be proved. Okay, first property 1, sine inverse sine x equal to x for x belongs to minus pi by 2 to plus pi by 2. So to prove this property, we are going to use the important property of bijective functions. Okay, I hope you remember the very important property of a bijective functions, and that important property we have discussed in the previous class also. Let me just repeat that property. What is that? If f is a function from a to b is bijective. Bijective means 1, 1 on 2. Then there exists another function f inverse from codomain to domain such that f inverse not fx always is equal to x. Is it not very interesting, this property? And with the help of this property, and this can be proved easily. Okay, now let us see that what will be fx here. In this regard, here fx will be the sine functions. Now let us see that when sine x function will be bijective, that means 1, 1 on 2. We know that the domain of sine x is set of real number, and we have discussed in details in the previous videos also that when you restrict the domain of sine x into some intervals, then sine x becomes bijectives. So one such interval is minus pi by 2 to pi by 2. So definitely sine x will be bijective functions from minus pi by 2 to pi by 2 with the range obviously plus minus 1 to plus 1. Okay, therefore if you restrict the domain to minus pi by 2 to pi by 2, sine x becomes bijective, and if the function becomes bijective, then the inverse of the function exists. Therefore, in this regard, if we directly use this property here, that since fx already you have discussed that sine x is bijective for x belongs to minus pi by 2 to pi by 2, so therefore sine inverse exists. So hence you can definitely write sine inverse sine x is equal to x. Here, if we just think, replace that f inverse is sine inverse and the function is sine x, so f inverse not fx is equal to x and sine inverse sine x. In fact, like if you use the definition of that composition function, you can just write in this way f inverse, and if you remove this dot, then there will be another bracket is equal to x. So you can directly prove this one with the help of only this property. And we can also prove this one with the help of some alternate method. Let us see the alternate method as well. Okay, alternate method, and this alternate method also just equally simple. Okay, just will assume like let okay sine x equal to theta, right? Sine x equal to theta, and here obviously that x belongs to minus pi by 2 to pi by 2. So therefore we are in a position to write x equal to sine inverse theta, right? We are in a position to write x is equal to sine inverse theta is equal to sine inverse, and what is the value of theta? Theta is sine x. Is not a very simple method. Okay, what we have done, just assume sine x equal to theta, but most interesting fact is why x is equal to sine inverse theta. We know that x is belonging to minus pi by 2 to pi by 2. That means we are restricting the domain to minus pi by 2 to pi by 2, and therefore sine x is a bijective functions, and you are in a position to write x is equal to sine inverse theta. Let x be there and sine inverse replace theta by sine x. Hence it's proved. Okay, you can try the similar other proofs, okay, either by the uses of the property or by the direct method. Let us see the other property. Okay, this is property 2. What is this property? Okay, sine inverse x equal to x for all x belongs to minus 1 to 1. Cos inverse x equal to x for all x belongs to minus 1 to 1, and similarly the other properties. Okay, now let us try to prove the property. In fact, this property also exactly the similar way that we have proved the property 1 can be proved. Okay, let us see that the proof. Okay, just what is the property? I'll just repeat the property. Okay, this is property 2. Okay, now what is the first property? That is sine inverse x. Okay, sine inverse x equal to x. Sine inverse x equal to x, provided x belongs to minus 1 to 1. Done. So now again, to prove this one, we'll be using the same property. What is the property? I'll just repeat once. If f is a function from a to b, it's in fact it's a very important property. F is a function from a to b. If f is a function from a to b is bijective. Bijective means 1 1 and on 2. Then there exists another functions f inverse from b to a. If f is a function from a to b is bijective, then there exists another function f inverse b to a such that another function f inverse b to a such that, okay, f not f inverse x, f dot f inverse x is equal to x. This is f inverse. So this implies, if you use the definition of the composition functions, fx is equal to x. So similarly, this property also can be proved with the help of this important property. Okay. In this regard, here f will be sine functions and the inverse function will be sine inverse. Okay. So both property, as I said before, that these are the very basic property 1, property 2, and you can prove this property also, the remaining property also, with the help of this important property of bijective functions. Okay. Next, let us go for the another property. Okay, that is third property. Okay, what is this property? And this is also a very important and useful property in inverse trigonometric function. What is that? That sine inverse minus x is equal to minus sine inverse x. And most important is this. That is x belongs to minus 1 to 1. Tan inverse minus x is equal to minus tan inverse x. Okay. Then sine inverse, tan inverse, cos inverse has got the similar properties, and similarly remaining three functions, that is cos inverse, sec inverse and cot inverse also has got the similar properties. Cos inverse minus x is equal to pi minus cos inverse x, provided x belonging to this minus 1 to 1. Similarly, sec inverse minus x is equal to pi minus sec inverse x, and provided mod x greater than or equal to 1, or x belonging to r minus 1 to 1. Okay, this condition and this condition are equivalent statement. Okay, and cot inverse minus x is equal to pi minus cot inverse x for x belonging to r. Okay, let us prove this properties. How to prove this? Okay. Okay, we'll be proving this property. Okay, the first property, that is property 3. Property 3, that is sine inverse minus x equal to minus sine inverse x. Remember this? X belongs to minus 1 to 1. Okay, sine inverse minus x is equal to minus sine inverse x. X belongs to minus 1 to 1. Okay, so how to prove this? Let sine inverse minus x. So assume that let sine inverse minus x, okay, is equal to y. Sine inverse minus x is equal to y. This implies minus x equal to sine y. Can you write like this? That is sine inverse minus x is equal to y. So minus x equal to sine y. Now what's the next steps? X equal to minus sine y. Okay, x equal to minus sine y. So next we can write is that x equal to sine. Okay, x equal to sine minus y. Sine minus y. Next. Okay, and sine inverse x equal to minus y. Sine inverse x equal to minus 1. Then if you transpose this minus sign this side, so y equal to minus sine inverse x. Done? Now we just replace the value of y. What is the value of y? Y is sine inverse minus x. Y is sine inverse minus x equal to minus sine inverse x. It's done. Okay, simple steps. You are assuming sine inverse minus x is equal to y. Okay, and therefore minus x is equal to sine y. And remember this, x belonging to minus 1 to 1. Now there is a very interesting property here. Since x belongs to minus 1 to 1, remember this x belongs to minus 1 to 1. That means x is greater than minus 1. Okay, greater than equal to minus 1 and less than equal to 1. Then what about the minus x? Okay, if I just multiply it by minus sign both sides, then it will be 1. And if I multiply it by minus 1, then the inequality changes. It's minus x greater than equal to minus 1. Down. For x belongs to closed interval minus 1 to 1, minus x also lies in the same closed interval. This minus x. Okay, therefore minus x is equal to sine y, and I hope that we have gone through the steps. X is equal to, and you are transposing this sign, and we know that minus sine y is equal to sine minus y, and therefore again in this place you can just take the inverse, that is minus y equal to sine inverse x. Okay, and y equal to then this y. If you transpose this minus sign this side, so y equal to minus sine inverse x, and sine inverse, then you just replace the value of y. Y is sine inverse minus x equal to minus sine inverse x. Okay, this is the proof of sine inverse minus x equal to minus sine inverse x. Next, we are going to prove another very important property. Okay, that is cos inverse minus x. Cos inverse minus x equal to pi minus cos inverse x. Okay, because already I said like three functions follow one particular pattern, another three functions follow another particular pattern. So I'll be proving one of it's the pattern. So cos inverse minus x equal to pi minus cos inverse x, and here also it's given that x belongs to minus 1 to plus 1. Remember this, x belongs to minus 1 to plus 1. Done. Okay, now how to prove this? Okay, prove. Let cos inverse minus x equal to sec theta. Theta y just you can write. Okay, now minus x is equal to cos theta. Already I say like if x belongs to closed interval minus 1 to 1, definitely minus x also lies between minus 1 to 1, right? Minus x equal to cos theta. This implies x equal to minus cos theta. Okay, what's the next steps, right? What is the next steps? This implies x is equal to minus cos theta. So minus cos theta, in fact here only that minus cos theta I can write in the form of cos pi minus theta, because we know like minus cos theta is equal to cos pi minus theta. Okay. Then next step we can just follow like cos inverse x is equal to pi minus theta. Done. Cos inverse x equal to pi minus theta. Okay. Next we can write the steps here. Okay. Now cos inverse x equal to pi minus theta. What is the value of theta? Theta is cos inverse minus x. Done. So now if you transpose cos inverse minus x, if you transpose this one this side, cos inverse minus x equal to pi, and you can transpose cos inverse x. Done. So what did you get? Cos inverse minus x equal to pi minus cos inverse x. The steps are simple. Cos inverse minus x equal to theta, then minus x equal to cos theta. We are transposing minus sign this side, then x equal to minus cos theta, then minus cos theta can be written as cos pi minus theta, because cos pi minus theta is minus cos theta. Then there is another important property here, and where is theta lies here? Theta here lies here. This theta. Theta lies between what? Minus. Here theta lies between 0 to pi, right? Here theta lies between 0 to pi. And if theta lies between 0 to pi, and you can show that pi minus theta also lies between 0 to pi, and therefore the next step obvious will be that theta, that is pi minus theta, is equal to cos inverse x, and cos inverse x is equal to pi minus cos inverse minus x. And if you transpose cos inverse x this side and transposing cos inverse x that side, so you got cos inverse minus x is equal to pi minus cos inverse x. Done. So these are the two important proofs of property 3. And next what I am going to do is we are going to take some important questions, okay, applications. We are going to solve some important questions, okay, and I have included questions from these are the properties that we have discussed now, especially from property 1 and property 2. Done. Okay. So we are going to take some questions, and these are questions, okay. Now evaluate. What's the questions? Evaluate cos inverse cos 2 pi by 3, tan inverse tan 3 pi by 4, and sine inverse sine minus 20, right? How to prove this? This is just one step answers. Now we know that cos inverse cos theta equal to theta, right? When if theta belongs to cos inverse cos theta equal to theta, when if theta belongs to what? 0 to pi, right? 0 to pi, and therefore cos inverse cos 2 pi by 3, and most important is you need to check like 2 pi by 3. 2 pi by 3 obviously lies between 0 to pi, therefore cos inverse cos theta is equal to theta. So it is your direct answers. Now let's see this. Tan inverse tan 3 pi by 4. Now for that you should know the property of tan. Okay, what is that the property? We know that property of tan inverse tan theta. property of tan inverse tan theta is equal to theta, and provided what? Theta belongs to, that is minus pi by 2 to pi by 2. That it should lie between minus pi by 2 to pi by 2. Now the question is whether 3 pi by 4 lies between minus pi by 2 to pi by 2 or not. So this 3 pi by 4, okay, does not lie between minus pi by 2 to plus pi by 2. It does not lie. Okay, therefore this tan inverse tan 3 pi by 4 is not equal to 3 pi by 4. How to solve this? Is equal to tan inverse, then you can simplify this. 3 pi by 4 can be written as pi minus pi by 4. Done? Because pi minus pi by 4 is 3 pi by 4. Now next, tan pi minus theta. What is tan pi minus theta? Tan pi minus theta is equal to minus tan theta. Done? Okay. Therefore tan pi minus pi by 4 is minus tan pi by 4. Minus tan pi by 4. Now we have another property, that is tan minus theta equal to minus tan theta. Done? Tan minus theta is equal to minus tan theta. Therefore, what's the next steps? Tan inverse, you can write tan minus pi by 4. Done? Can you write like this? Tan inverse tan minus pi by 4, because these are two equivalent statements, like minus tan pi by 4 is same as tan minus pi by 4. Now the question is whether this minus pi by 4 lies between minus pi by 2 to plus pi by 2. Yes. So this value, that is minus pi by 4, lies between minus pi by 2 to pi by 2. That is, and therefore the value of tan inverse tan minus pi by 4 is minus pi by 4. Right? Done. Okay. Next we are going to solve this. That is sine inverse sine minus 20. How to solve this? Okay, this question it's a little different than the other questions. Okay, let us see how to solve this. That is sine inverse sine minus 20. Done? Sine inverse sine minus 20. This is equal to sine inverse and sine minus theta. How to write this? Sine minus theta? Like sine minus theta can be written as minus sine theta. That is 20. Done? Okay? Minus sine 20. Next, sine. Okay, can you write this value? Okay, remember, like, it's minus sine theta. And here the value is sine 20. So can you write this? Sine, okay, 6 pi, like I'll show you 6 pi minus 20. Now, what is 6 pi minus 20? Then what is 6 pi minus theta? 6 pi minus theta will be in this quadrant, that is 4th quadrant, right? 6 pi minus theta. And what is sine 6 pi minus theta? Sine 6 pi minus theta. And I know, like, why you might be thinking why I am taking 6 pi minus 20. What is the reason for this? I'll explain you. Obviously, that sine 6 pi minus theta is equal to minus sine theta. Remember this, what is this functions? This is sine functions. And let us see the property of sine. Okay, what is the property of sine? Okay, the property of sine satisfies us. What is that property? Sine inverse, just now we have proved this. Sine inverse sine theta equal to theta. Okay, in case theta belongs to what? Theta belongs to minus pi by 2 to plus pi by 2. Okay, it's minus pi by 2 to pi by 2 plus pi by 2. So therefore this 6 pi, you have to write an angle here so that this 6 pi minus 20 should lie between minus pi by 2 to pi by 2. Okay, now if you calculate 6 pi minus 20, obviously 6 pi minus 20 will lie between minus pi by 2 to plus pi by 2. That's the reason, because it's 20, so you need to multiply pi with such a multiple that it comes closer to 20. That's why we have taken 6 pi minus 20. Now, since 6 pi minus 20, since 6 pi minus 20 belongs to minus pi by 2 to plus pi by 2. So it exactly will follow this condition, sine inverse sine theta equal to theta. So this is equal to 6 pi minus 20. So this is a little different than the question that we have done. So like this, I have given you some more questions. Okay, we have got more questions here. Like this is cos inverse cos 15 and tan inverse tan minus 6, cosec inverse cosec 7. Done. Then we'll be taking some questions, right? Then we'll be taking some questions from this side, that is sine cosec inverse 17 by 8, cos tan inverse 3 by 4, etc. Okay, this is basically the uses of the property 2. Let us see that. Okay. So these are the properties, not this. Okay. Yeah, these are the properties. Okay, evaluate. Sine cosec inverse 17 by 8. It is, see that how to prove this. Okay, 1. What is that? Sine cosec inverse 17 by 8. Okay, and let us see that what is the property related to sine. We got this, that is sine inverse theta equal to theta. We got this. Sine inverse theta is equal to theta. We know that. And what was the condition for theta? It's lies between minus 1 to plus 1. Done. So now sine is alright, but this is not sine. So we'll convert this cosec inverse to sine inverse. How to do that? For that, you need to draw one triangle, right triangle, of course, right triangle. Now cosec. Cosec means what? That hypotenuse by perpendicular. So it's 17 and this is 8. 17 and 8. So you convert cosec to sine inverse. How can you do that? Sine, right? That cosec is that hypotenuse by perpendicular and sine is perpendicular by hypotenuse. So therefore cosec inverse 17 by 8 is sine inverse 8 by 17. Done. Now we need to check whether it is 8 by 17, it's actually lying between minus 1 to 1 or not. Since 8 by 17 lies between minus 1 to 1, therefore sine inverse sine inverse 8 by 17 is 8 by 17 by the property 2. Okay, it's property 2, and only you need to know today, and we are going to solve more questions on that concept, that how one inverse trigonometric function can be converted to another inverse trigonometric functions with the help of a right triangle. Let us solve these questions. That is question number 2. Okay, what is question 2? Question 2 is cos, that is cos tan inverse 3 pi by 4. Done. Cos tan inverse 3 pi by 4. Actually, this should be tan inverse 3 pi by 4. It should not be pi. In fact, it should be 3 by 4, right? Not 3 pi by 4. It should be 3 by 4, right? Yeah. This should be 3 by 4, right? Okay. Now, cos tan inverse 3 by 4. Now we'll just convert. Similarly, the tan inverse will convert to cos. So for that, we'll just draw the triangle. Okay, right triangle. Tan means what? A perpendicular by base. So it's perpendicular, it's base, right? Then what will be the hypotenuse? Hypotenuse will be 5. Done. Now cos. So we'll convert tan inverse to cos inverse. Okay, what is cos? Base by hypotenuse, cos. So therefore it will be cos inverse, okay, base by hypotenuse, that is 4 by 5. Done. This is cos inverse 4 by 5. Now you need to check, like 4 by 5. What is the property of cos? The property of cos was cos inverse theta is equal to theta, right? And what is the value of theta? Here also, the theta should lie between -1 to +1. Now, what about 4 by 5? So 4 by 5 definitely lie between -1 to +1. So therefore is equal to 4 by 5. Done. Okay. So this is also another very important property applications. Okay. We have more different questions on that, and we'll be taking another important questions. Okay. These questions we are going to solve this, and I'm just leaving other questions as for you, like you need to solve this and similarly solve more questions. Okay, now just we are taking 2 basic questions on solutions, how to find the value of x, and out of that, like we are going to solve one question. Such one important question is this. Okay, let us see these questions. Yes, this is the questions. Let's solve. Sine inverse 1 minus x minus 2 sine inverse x equal to pi by 2. How to solve this? Solve means to find the value of x. Okay. So what I'm going to do is, we'll assume the value of x. Let x is equal to sine y. Since it is sine inverse x, so we're just assuming x in terms of sine. X is equal to sine y. Therefore, sine inverse 1 minus sine y, done, 1 minus sine y minus 2 sine inverse x value is what? Sine y equal to pi by 2. Done. This implies sine inverse 1 minus sine y. Now what is 2 sine inverse sine y? It's minus 2y, because sine inverse sine y is y. So y equal to pi by 2. Done? Yes. And next, what is the next steps? Okay, and if you are solving this, try to pause the video and first you solve and then you compare the answers. Then you will definitely enjoy in case you can solve by yourself. Okay, next. Then sine inverse 1 minus sine y equal to pi by 2 plus 2y. You transpose 2y that side. Okay, next. What is the next steps? That is 1 minus sine y, 1 minus sine y. Okay, 1 minus sine y. 1 minus sine y is equal to, that is it is sine inverse 1 minus sine y. So 1 minus sine y is equal to sine pi by 2 plus 2y. Done. Okay. What's the next steps? 1 minus sine y, sine pi by 2 plus theta. Okay, sine pi by 2 plus theta is equal to cos theta, cos 2y. Done. I hope like now by this time like you have done this, and okay, next, what is the next steps? Simple steps. 1 minus cos 2y, and we transpose sine, it's y, sine y. Done. Now we'll be using the formula of 1 minus cos 2y. What is the formula for 1 minus cos 2y? Is 2 sine squared y equal to sine y. Now only 2-3 steps are left, right? Okay, we are today explaining some important, like initial the properties of inverse trigonometric functions, and slowly we will keep on increasing the number of inverse trigonometric functions property in our next videos, and will include the most important, the property of inverse trigonometric functions, and where you will get lots of applications. And these students, like inverse trigonometric functions has got properties, as I told you before, and you want to master the chapters, you need to know the properties and their most important the conditions. Okay, that means the restrictions. For that, you need to have a regular practice on this. Okay, next, what is the last steps? This implies, okay, 2 sine squared y minus sine y, right, equal to 0. You can take sine y common. Okay, sine y common, then it's 2 sine y minus 1 equal to 0. This implies either sine y equal to 0 or sine y equal to 1 by 2. Sine y equal to 1 by 2. Now let's see, like, what did you assume? You assume x as equal to sine y, done? Okay, so what's the next step? Next step is x, because you assume sine y as x, so x is equal to 0 or x is equal to half. Okay, x is equal to half. And in case, like, we'll need to check, like, you got the two answers, two solutions, x is equal to 0 and x is equal to half. Now we need to check, like, whether both the solutions are possible or not. Now you can check yourself, like, if you substitute x is equal to half, okay, a left hand side is not equal to the right hand side. If you check that, okay, that you can do yourself, you will check this. And not only for x is equal to half, generally while solving this, we need to check the values, like whether it's possible or not. So here in this regard, that x is equal to half will not satisfy the given equations. So therefore, we'll have left to it only one solution, that is x is equal to 0. Okay, and this is one very important questions. And I'm just introducing the solution because we have got many solutions, many different varieties of questions are there. Okay, and we'll again include, as I said before, I will include again 2-3 properties in the next video. Okay, and thank you so much, and solve questions based on these properties. Okay, and solve from the textbook, exemplar, or from the other reference book, and gradually you try to improve the concept, the basic concept and applications. Okay, and thank you so much for watching my video. Thank you.